Hello everyone, the title of our project is Neural Style Transfer using CycleGAN. It's a type of image-to-image translation problem where the goal is to learn the mapping between an input image and an output image using a training set of aligned image pairs. Our neural style transfer is one way to perform this image-to-image translation where we try to synthesize a novel image by combining it with the content of input image. Recently, the work focused on a neural style transfer used paired image dataset. In this project, we use unsupervised method called CycleGAN, which learns to mimic the style of an entire collection of artwork rather than transferring the style of a single selected piece of art. The dataset used for this project can be downloaded from TensorFlow official data collection website. It consists over 6,000 images of landscape, which can be attributed as domain Y, and dataset of 4 different artists, which can be attributed as domain X. And for each experiment, we take the data in domain X comprising only from one of the artists, so that we can transfer the artist style to domain Y. Now, we have two domains, X and Y. We have two generators, G and F. Also, we have two discriminators. So generator tries to generate new images and discriminator judges whether that image is real or fake. So the first objective is to learn this mapping G and F and discriminator dx and dy. So for this, we use adversarial loss, which directly comes from the original GAN paper. Then, since we don't have any paired data to train on, there is no guarantee that the input and the output and the target pair are meaningful during training. So in order to enforce that the network learns the correct mapping, we use the cycle consistency loss for that. Moreover, the identity loss we use to make generators generate the same input if the input image belongs to their target domain. Also, it has been observed that this identity loss function also helps preserve the color of the input paintings. Now, in summary, the total loss is nothing but the sum of the following three losses. Now, talking about the network architecture. So for generative architecture, we tried two different type of configuration. The first one is the ResNet, which is nothing but the residual comprising of residual blocks. And the second one is UNet, which is nothing but an encoder-decoder network with some skip connections between the encoder and decoder. Also, instead of batch normalization, we are using instance normalization, as experimental results have shown that instance normalization perform really better in the application of GAN. For discriminator, we try to classify each n by n patch, whether it's real or fake. Hence, it is termed as patch GAN. Also, when n is equal to 1, we term it as pixel GAN, and when n is equal to whole image, we consider it as image GAN. For patch GAN, we use n is equal to 16 and 70. For training, we used random jitters to generate the dataset, and we use Adam optimizer with a batch size of 1. So, all right, so now let's talk about the experiment. So the first one is we learn the mapping G and F. So this domain is basically the the landscape. We convert it into paintings with different styles. So you can observe the input image with respect to the style of different artists, and the results are quite good. Also, this is another set of images. The other thing is now we want to convert from painting to real landscape. So how the painting would actually live in real life, and we can see it performs really, really good. All right, we also compared our method with the recent neural style techniques. So we compare the result with Gates and Johnson. So Gates and Johnson, they use one fixed style and they merge it with the content of the input image. Here we don't do that. We just learn the mapping between the whole domain X and whole domain Y. So let's say this is images from Van Gogh, and we just learn the mapping, and we can see we are able to generate really good, and they are quite natural looking too indeed. Also, we try different generator architecture, for instance, ResNet with batch and instance and UNet with batch and instance. And we can clearly see ResNet with instance normalization performs way better. It essentially captures the style and the other one fails to capture any style and they look exactly like the input image. Also, we tried different patch sizes. So the pixel GAN seems to not work. As you can see, it looks kind of exactly like the input, and if you zoom in you can see the grid created in image. The patch can seems to be work really well, especially n is equal to when n is equal to 70. For n is equal to 16 you can see some artifacts are created around the borders of the image which are not very good. And for the image scan we can see the style is not captured very well, and also the images seems to be very warm. Also, we try different padding types, nothing fancy here, and we can see the reflect padding seems to work the best. Also, initially we tried for adversarial loss, we use binary cross entropy loss function, but we observed that the model was very unstable and very oscillatory. Based on some recent literature, we change it to mean squared error, and then it seems to perform the model was very stable during training. So in conclusion, we used the unsupervised method called CycleGAN to tackle this problem of neural style transfer, and the results that were generated were even better than some of the recent neural style transfer techniques. That's it. Thank you.